All right, so this is section 2.6 continued. We're now going to write the piecewise functions, meaning you're going to be given a graph like the ones you see here, and you'll be asked to write the piecewise function for it. Here we go. So here is an example of a piecewise function graph. You are going to write the equation. So when you do that, please use function notation. So choose favorite letter, f of x, g of x, q of x, m of x, right? Something of x. So f of x equals, and then give yourself a nice bracket. You can do a squiggly bracket, or you can do a square bracket. It's a little less common. I usually go for the squiggle. Right? If we have two pieces here, we're going to use two equations. So let's focus first on this line right here. Okay, I'm just choosing that one first. It really doesn't matter which one we do first. So for this line, you'll notice that I'm giving you, and I will do this often, some points here, right? And I'm giving you those nice points because a lot of these times these graphs are not perfect. So, human error of drawing it by hand, or the computer just gets a little blurry when it's like copy and pasted. So I will often draw these additional points here for you so that you have ordered pairs to work with. Please use those ordered pairs to help you. Okay, so I'm looking at this first line and I'm thinking, okay, this is a line. So how do I write the equation of a line? Y equals mx plus b. So I need two pieces of information to get this equation. I need m and I need b. So use the 2 points that I gave you, that I bolded, right, that I drew dots for. Use those 2 points to find the slope, right? So rise over run. This is, up 2 over 1. So that's our slope is 2, and it's positive because Bob is climbing up the hill from left to right. So that's our slope. What's the y-intercept? Again, here on this problem, it is crystal clear to us, right? 1, 2, 3. So now with those two things, the equation of my line is y equals 2x plus 3. When you write it into your equation here, don't put y equals, because you already have f of x equals 2x plus 3. Now, if. After the if, you're going to say, when is this line used? So find your open circle. Where is our open circle located at? It's located at an x value of 1. So if x is something with 1, right? Would I put a less than symbol, a greater than symbol, or less than or equal to, or greater than equal to, right? So for this question, I know it's an open circle, so I'm only debating between this and this. And because it's going left of 1, I want to use the less than sign. All the numbers that are less than 1. That's your first equation. For the second line, we have this closed circle and then a horizontal line to the right. So how do you write the equation of a horizontal line? It's just y equals and then some number, right? So what's that number? Well, how high am I? 1, 2, 3, 4, 5, 6, 7, right? So my equation would be y equals 7. So f of x equals 7 if, and then if x is greater than or equal to 1. And that was it for this graph. Now, before we do the next example, a quick note about quadratic functions, right? Quadratic functions is anything with an x squared in it, and we talked about in class that those are parabolas. Your most basic parabola that we call the parent function is y equals x squared. It has a vertex at 0, 0. Then it would have, 1, 1, 2, 4, and it is symmetrical. So this is what that quadratic would look like, right? In this class, for right now, all we're going to do is shift this up or down, so a vertical shift. If I move that vertex down, let's say 3 units, everything is just shifting down 3 units. It would look something like this. If that happens, your equation becomes y equals x squared minus 3. Same thing, let's say I shifted it up 2 units. It would be y equals x squared plus 2, right? So this second number here is your vertical shift, either up or down. So that's all we're going to do for now for this section. And so here we go with the next example that has a quadratic in it. So f of x equals, I've got this parabola here. So in my mind, I'm thinking something about y equals x squared. This is the parent function. It has that vertex at 0, 0. It's got 1, 1, negative 2, 4. So it is the parent function. So just f of x equals x squared. And then if. When do I use this parabola? Well, I see this closed circle here at 1, 1. And it goes to the left of that. So if x is less than or equal to 1, and it's going to continue, it's got this arrow, it's going to continue forever to the left with no ending point. All right, the next piece I'm looking at is this horizontal piece right here. I know this is the line y equals 3. So f of x equals 3. If, when am I using it from? Now this one does not go forever left and forever right. It is in between two numbers. It's in between an x value of 1 and an x value of 2. So I'm going to write that my x value is between 1 and 2. The 2 has a closed circle, the 1 has an open circle. And the last piece of this piecewise function, open circle here, headed in that direction. So again, I'm thinking y equals mx plus b. So I need to find the slope. I need to find the y-intercept. For the slope, just look at your rise over run. There were no points plotted here, but this one's crystal clear, right? It hits so nicely on those coordinates. So rise over run, it's a positive slope, 1 over 1, which is 1. Now the y-intercept, this green line, does not hit the y-axis the way it's drawn right now. So you have to imagine, if I continued this slope and continued this line in the other direction, where would it hit? And lucky for us, it hits perfectly at 0, 0, so my y-intercept is 0. So the equation of this line is y equals 1x plus 0, which we just write as y equals x, right? What would happen if this green line didn't hit nicely at an ordered pair that's integers? Like what if it hit at a decimal or a fraction? We're going to cover that in class tomorrow. Get excited. So f of x equals x. If, when was I using this green line? Let's go back and find that open circle. That open circle was at an x value of 2. So if x is greater than 2. And there you go. So we'll continue this lesson in class tomorrow with some different examples. We'll also, practice domain and range with this as well. If you want to go back and practice domain and range with these two examples we just did, that would not be a bad idea. All right, see you guys soon.